Hi, welcome back to our first actual content lecture on Straightedge and compass constructions. So you'll see my setup. I'm using GeoGebra. Personally, I think I prefer actual compasses and straight edges and doing it by hand just because it feels cooler, like it feels like you're actually doing something. But it's hard for me to record that and have my face. I like to have my face in the frame so you can see me. But yeah, it's hard to do both of those at the same time and to give you a good clear view of my drawings if I got my hand in the way, right? So I wanted to sort of, get rid of all those issues and use GeoGebra. So I'm going to use GeoGebra. You can do whichever you prefer. All right, let's get started. So whenever you're doing any straight edge and compass constructions, everything starts based on 2 points. Why do we need points? Well, you need like a reference, right? So the first thing you need like a physical single point reference to show where everything is centered around. So usually we put that at the origin. And usually, although it doesn't really matter where you put it, but usually we put it at the origin and usually we call it O. We call it O. Perfect. The second thing you might be wondering is, how do we measure distances? Well, in order to measure distances, you need 2 things, right? So to have like a distance between things, you need to have at least 2 things. So for us to be able to do anything with distance, we need to have a second point, which I'm going to put here at 1 and 0, although again, it doesn't matter where you put it. And I'm going to call it A. So this is the notation of the textbook, that you have O and A as your 2 starting points. What you call them doesn't really matter, and where you put them doesn't really matter, and even the orientation. So like hypothetically, you could have like O here, and you could have A over here, and it doesn't matter. All the math stays the same. It just would be stretched and rotated, right? It's often nice to do OA like this, but yeah. And I should also say, going forward, I probably won't use like labeling and actually calling one O and calling one A. I'll just assume that the first 2 points that I place are O and A. They're always just going to be 1 for the reference and then 1 to define a distance of 1, right? The other thing I should mention is that it's always assumed that the distance between O and A is 1. So 1 unit, right? Everything else is done in reference to that single distance. So for example, if I had an O here and I had an A here, then the distance between those 2 points we would define to be 1 unit. Then as an example, this point here would be the distance between this bottom point here and this top point here would be 2 units, even though if you actually like measured the distance, even using GeoGebra, we can measure a distance. It's 7.211, right? That's what the actual distance is based on the grid, but using our definition of 1, we assume that the distance between these 2 is 1, so 3.6 is 1. So if 3.6 is 1, then 7.2 is 2, right? It's double the base unit. So hopefully that makes sense. I'm going to get rid of those points. All right. Next up, we are going to start constructing. So the first basic thing that I think most people will start constructing is perpendicular lines. And that feels like it's obvious. It feels like maybe not so obvious that it's like sort of different. Like, why would you do perpendicular lines? Why not parallel lines? Those seem simpler. Or why not something else, right? And you'll see that the reason we do this is really just ultimately comes down to it's the easiest thing to construct using circles. Why is perpendicular so easy to construct using circles? I don't know. I'm going to show you how it works out, though. So what I've done here is I've drawn 2 circles around O and A with a radius 1. So the radius is the distance between O and A. I've drawn 2 circles, one around O and one at center of A. And those 2 circles have a connection point. So we have 2 connection points. We have 1 point there really the way I should do this using GeoGebra is go intersect, boom, intersect, boom, and then compass, oh shoot, sorry, not compass, segment. So I'll connect those 2 points, and I'll connect O and A, and you always will get a perfect 90-degree angle. So we can construct a 90-degree angle, or we construct perpendicular lines. That's an easy one. And I think you might remember, if you watched the 0 lecture, that you can also make a triangle. So instead of doing what I just did there, when you make these two, you could start by connecting O and A, and then you could do a line connecting the new point, one of the points to O, and one of those points to A, and you get a triangle. So you can make triangles. Perfect. Okay. Maybe I should talk a little bit about what I mean by like make. So there's sort of 3 operations you can, well, there's 2 operations you can do. You always start with 2 points in any of these systems. You can always connect any 2 points. So that's one thing you can do. You can draw a line between 2 points. You can extend that line as far as you want in any direction. So I could like extend this line infinitely across. So sometimes we will do that. Maybe I'll use ray at some points just to show if I only want one direction, but either way, it doesn't really matter. The other operation you can do is you can do a circle of radius the distance between 2 points. It's always got to be like a distance like that. So for example, what I couldn't do is I couldn't go compass here, here, or I don't even know if I can do it. Maybe I can't, but I couldn't just arbitrarily have like a random, non-unit circle sized. And I think GeoGebra sort of restricts you to that. Sorry, I said non-unit circle, that's not what I meant. A circle that isn't a distance between 2 points in terms of its radius. So it always has to be like that. And I think GeoGebra does a good job of restricting you to that. As another example here, I could use the distance between, say, this point and this point to be my radius. So it doesn't have to be 1, right? It just has to be of a certain radius like that. And I can, I technically can't put this circle here because it doesn't, like, it's not the distance between O and another point, right? So it would have to be centered at one of these 2 points if I had a circle of that radius. The other thing I should mention here with this is that another way to look at this is that any circle you draw using the compass has to have a center of one of the points, and a second point has to be along the circumference, somewhere around the edge of the circle. So a point has to be on the circle. So hopefully that makes sense. And delete all of that. Let's put our 2 points back, O and A. I don't know why I put that at A at 0.5. It doesn't really matter. You can put it wherever you want, but I like to have it at 0 and 1. All right, so we got this. Let's move on and talk about how you can add points. So you're allowed to add points in 3 cases. The first case is where you can add a point wherever a line and a circle connect. Awesome. What does that mean? So let's say, for example, I'm actually just going to get rid of these references. I'm just going to say, pretend you already have like a line that's somewhere, and you have a circle that's somewhere, right? So you got a line and a circle. You can find the intersection between a line and a circle. That is allowed. And you go intersect, boom, intersect, boom. There you go. You can find the intersection between a line and a circle and put a point there. That can be a point. You can also find the intersection between 2 lines. So let's do that. Maybe I'll just undo a bunch of this. There we go. Let's say you have 2 lines, so maybe that's 1 line, and maybe your second line looks like this. There you go. You have 2 lines, you can find the intersection point between those two lines and put a point there. That's allowed. And the last thing that's allowed here is to find the intersection point between two circles. So if I have a circle here and a circle here, well, it has two intersection points, and the intersections are there and there. There's your two intersection points. All right, I can put points where circles intersect anywhere I want. All right, cool. So to recap, you start with two base points, O and A. You are allowed to draw circles around any point such that a second point is on the outside of the circle, on the perimeter, the circumference of the circle. So you're allowed to do circles like that. You're allowed to connect 2 points using a line, and you can extend that line as far across as you want. So those are the two operations you can perform. And then to add new points, you can do it in 3 ways. Either circle intersects with circle intersects with line, or line intersects with line, which should make sense, right? Like, I think a lot of this is fairly straightforward, maybe obvious, but I just want to make it clear that those are the rules we're using. You cannot, under any circumstance, pick a random point, because that is not allowed. The only random points you can pick are O and A. Those two, and that's it. Okay, once you've picked those first 2 reference points, everything else has to be an intersection of something. Awesome. So it seems fairly simple, and maybe it almost seems like you can't actually do that much. Like, maybe it seems sort of restrictive. But it turns out that it isn't. You can do quite a bit. So we're going to show you what numbers can we reach. And what do I mean by numbers? So one way I can look at this is I can label these points. So I can say, instead of calling this O, well, maybe I'll call it O, and then I'll give it a name. It's 0, 0, right? So O is the point 0, 0, and I'll show that label. And then A is the point 1, 0, and I'll show that label. So we've got those 2 points. So instead of referring to them as O and A, just briefly here, we're going to call them 0, 0, and 1, 0. Okay, cool. So we have these 2 points. Can I reach... So maybe to start, the question is, could I reach 2? Is it possible for me to reach the number 2? The answer is yes, it is. You sure can. You can reach 2, 0. How do we do it? We construct a circle around A of radius 1. Draw that circle. We construct a line between O and A, and we take the intersection between the circle and the line. So this circle, this line, intersection is this point here, which I'm not going to give it a name. I'm just going to go straight to the Cartesian coordinates 2, 0. There you go. So we've got 2, 0. Can we get 3, 0? Yes, we can. How do we do that? We simply do the same thing again. So we go, okay, let's draw a circle around 2, 0, and it intersects with that line at exactly 3, 0. So I think you can sort of imagine how you could construct every integer or every natural number as you go across, right? So you could construct 3, 0 here. I'll show label. You could construct 4, 0. You can construct 5, 0. So you can hit any number going across here. Could we hit the negatives? That's a very valid question. The answer is yes, we could. So if I do this, we'll do the circle here, unit 1. It connects with negative 1, as you'd expect. So I'll intersect, boom, like that. Then we'll do the circle with, the wrong tool. We'll do compass, boom, intersect, boom, compass, boom, and intersect, boom, and we've just hit -3. We can keep going. We can hit, -4, -5, so on. Perfect. Okay. So I'm hoping I've convinced you that we could hit any integer number, positive or negative, with 0 as the second coordinate. So we can hit all the way across. Can we go up and down? This might seem like a relatively easy question. So at first you might look at this and you might say, yes, we can, because this 0, or this circle here at 0 intersects with 1. But does it? Well, it does hit 1, the circle, but there's no line there. And we can't draw a line there because there's no 2 points to draw that line, right? So all of our points are along this horizontal line. We can't actually get up that easily. But what we can do is something a little bit sneaky. And it involves the Pythagorean triple. What is the Pythagorean triple? So I've never actually used this thing, so I'm going to try and, let's see, 3 squared. If you go into your calculator and you do 3 squared plus 4 squared, you're going to get 25, which is 5 squared. So we say that 3, 4, 5 is a Pythagorean triple. So hopefully that makes some sense. We say it's a Pythagorean triple because they're integers, and it works out nicely that 3 squared plus 4 squared is 5 squared. Awesome. Okay. So from this, can we go vertical? What does this have to do with vertical? Well, if you think about this, so if I wanted to reach, like go to Pythagorean theorem, right? And say that I wanted to reach 4 up here. Say that I wanted to reach this point 4. 0 and 4, let's say, right? What I could do is I could start at 3, right? I could construct a triangle, a right angle triangle that has a base of 3 and a height of 4. And then we know that the hypotenuse of that by this Pythagorean triple idea would have to be 5. It would have to be a length of 5 units. Okay, so what does that mean? Well, what that means is that I can go ahead and go compass and do a circle of radius 5, which means I would have to go through to -2 here. Draw that circle, and you'll notice it exactly goes through 4 and -4 on the top and bottom. I can do the same thing going through -3 like this, radius 5, center is -3, and now I have 2 circles that intersect at -4 and +4. So I'll add those points. Since they intersect, the circles intersect, I can add those points. So we now have new points. We have this point here, which is, we're going to call 0 and 4. I'll show the label. And then this one here, which we're going to call 0 and -4. So I can construct 2 points that are in my sort of horizontal space. And now that I've done this, I can draw a line. So I can just go line between 0, 0 and 0, 4. I've got this infinite line. And now that circle intersects with 1. So I can go, okay, let's add a point where they intersect. And then let's do compass, draw another circle, right? Oh, now it intersects with 0, 2. So I can go intersect, boom, and draw another circle, boom. It intersects with 0, 3. Great, right? So we could just keep doing this, and now you can hit, I think you can pretty easily see how we could hit every positive or negative integer and 0. So we can hit both axes. Can we go off the axes? Could we get, say, 1, 1, or 1, 5, or 3, 7, or some other point on this grid? How would we go about this? Well, what we would do is, and maybe you can already sort of see it, we can hit, for example, 1, 1, because we already have 2 circles that are intersecting at 1, 1. The circle that we drew at 1 and the circle that we drew at 1 on the x-axis. So I can put that intersection point, there you go, we have 1, 1. We can go off axis. Awesome. From there, I can draw a circle around that point like this, and you'll notice that now I can hit 2 and 1. So I've got a point here, like this, and I've also hit this point up here, 1 and 2. So I've got this point here. And I think now you can see how you could construct any point going along this grid, right? We could just keep repeating this process. So we'll go to a couple definitions here. We say that, so by definition, we say that O and A, we call them constructed points. So we define those two to be constructed points, whatever you pick your O and your A to be, your two starting points. And then from that, we say that any point that you can build using this straight edge and compass construction is called a constructed point. Awesome. So a constructed line is a line that you can construct between 2 points. And a constructed circle is a circle that you can construct using a center of 1 point that passes through a second point. This is exactly what we talked about, right? So all of these circles are constructed circles, we would call them. Okay, a constructed number, so I'm giving you a bunch of definitions here. A constructed number is any number where that number appears or could appear as one of the two coordinates of a constructed point. So in this case, we've just shown that every integer number, positive or negative, is a constructed number. Now the question arises, could we have points that are at fractions, right? Is there a point at a half that we could have, right? Let's take a look into this. So what we're going to do is I'm going to delete all of this now that we know we could create a grid of points in integers. Could we create points that are fractions, right? The rational numbers. Are the rational numbers part of these constructible numbers or the constructed numbers? The answer is yes. And I'm going to show you how you can hit any possible fraction you want. Okay, so let's say that you want to hit the fraction, I'll just add it by text here. Let's say that you want to hit the fraction, I don't know, 4 over 3, right? And just to be clear a little bit here, 4 over 3 is roughly equal to 1.3333 repeating, right? Cool. So we want to get that number, and we want to show that that is a constructible number. Okay, how do we do this? What we do, we start with our O and our A, just like normal. We have our 2 points, O and A, and I'm going to label them using our standard notation here. Show label, I'll do this one, call it A, so this should be 1, 0, show label, there we go. Okay, what I'm going to do, I know I can hit any point on the integer, so I'm just going to draw the points instead of constructing all the circles to get up to them. Okay, first thing I'm going to do is draw a, well, let's start by doing the point 4 and 3, like this. There we go. Then let's do the point 3 and 3. We'll make that point. So we could construct both of those points normally. I'm going to label them. So this is 4, 3, and this is 3. There we go. Okay. Perfect. So we've done this. I could also construct the point. Let me just open up my notes here so that I don't absolutely mess this up. Perfect. I did actually mess this up. I'm going to make this point 3, 1. That's actually perfect. Why? Oh, there we go. Perfect. Okay. 3, 1. So I have point 3, 1. I also have the point, I can obviously construct the point 0, 1. That was an easy one for us to construct, which I'm just going to do 0, 1. Perfect. Okay, so we've got this set up. Now, what we do is we go and draw a line segment between 4, 3 and the origin. And then we draw a line segment between... did I make a mistake here? I feel like I made a mistake. I think we're good. Oh, this point is at the wrong point. That's my problem. Okay, sorry. This series is going to be pretty much like this. So, apologies in advance. Let's start that demo over. We have our point O, which is 0, 0, show label. We have our point A, which is 1, 0, show the label. And then we have this point here, which I'm just going to click show value because I think that'll work fine. So we're going to do the point. We're doing 3 over 4. We want to do 4, 3, which is I think what I typed but not what I actually put in. And then we're going to do the point 4, 1. So there's 4, 1. Okay. Show value. Perfect. Now once we've done this, we draw 2 line segments. We draw a line segment, a horizontal line segment between 0, 1 and 4, 1. And then we draw a segment between, on the diagonal here, between 4, 3 and 0, 0. We find their intersection, and then I'll turn on the value of that intersection, and you'll see that it's 1.3333 repeating and 1. So this is 4 over 3 with 1. Awesome. Let's do another example. Let's delete this. We start with our 2 points, like this. How do we get, say, 5 over 7? So say we want to get the number 5 over 7. I think that's like, what is that? Like 5 over 7 is, I don't know, 0. 7, 1, 4. Is that right? Or is it? Should be 6, 1, 4, 2, 8, 5 ish. Okay, I'm thinking through that on the spot. I think that's right. All right, let's try it. So we put a point at 0, 1. We put a point at 5 and 1. Then we put a point at the fraction we want, 5 and 7. Then we draw our lines. Segment between here and here. Segment between here and here. Then we find their intersection. And then we pray while we turn the show value sign on that I got the number right, which I did not. It's 71428. Sorry. Not 61428. Just made a math error. Either way, that is 5 over 7. So hopefully I've convinced you that you can produce any P over Q that you want by doing this weird intersection of a horizontal line with a diagonal. If you do this approach, you will always get this result. Okay, so you can hit any rational number. The other thing that I should mention is that you can hit non-rational numbers, irrational numbers. So it's not just rationals. As an example, you could hit, well, let's see, you could hit, if I put a point at 1, 1, I'll start with my basics here. I will draw a circle around 0 of radius 1. I will draw a line segment between 0 and that point, which I can create using the methods we described earlier. The intersection point there, if I show the value, it's 0.707106778. Yeah. for both points. That number is the square root of 2 divided by 2, which is odd, right? Because now you're getting square roots, which are irrationals. So yeah, constructible numbers aren't necessarily just the rational numbers, right? So it includes all the rationals, it includes all the integers, and it includes some of the irrational numbers, but not all of them. You can't get every irrational number using this method. Yeah. Okay. So let's talk about one last thing here before we end this video. First, I want to talk about how you could do what we call bisecting and trisecting a line segment. So say we have this line segment here. We're just going to start with OA as our line segment. And actually, maybe just to make it more interesting, I will make the line segment, make OA and pick them to be something different than we've usually done. So let's say that, just for sake of argument here, that this is O and that this is A. And we draw a line between them, a segment between them, like that. Can we divide this line in half? Could we find a point that's exactly in the middle of O and A? Well, yes, we can. And maybe you would do this normally using like a ruler and something and measuring the distance, but no, you don't have to do that. We're straightedge and compass constructors, so we can do this without needing rulers. Who needs rulers, right? They're messy. So I'm going to draw two circles like we did before, and I'm going to find their intersection. Boom, boom. And I'm going to draw a line segment between them. Boom, boom. And would you look at that? That is exactly the midpoint, right? This is perfectly in the midpoint. If I display the values here, let's do show value. Let's do show value. Show value. You'll notice that this is -2 and 2.5, which is precisely in the middle of those 2 points. It always will be. When you do it this method, it always will be. Can we trisect points? So let's say I have this point here and like this point here. So there's our 2 points. Doesn't really matter what they are, but we've got these two. Let's draw the segment between them. Perfect. We want to trisect it, so we want to cut this into 3 even pieces. So find 2 points so that it divides this line into 3 even pieces. How do we do this? Okay, it's hard, right? This is a hard question. All right, so what we'll do is we will start. I'm just going to go off of my notes here just so we don't cause any issues. We're going to start by getting a circle of radius, the distance between the two, and we're going to draw it at one of the points. And maybe I will label them just because this is probably going to get pretty messy if I don't. Sorry. So let's call this one A. We'll show the label. And we'll call, actually I should want to call this O. And then this one is A. Show the label. Great. We've got our 2 points. We've drawn a circle around them. And then from here we will, okay, drawn the circle. Next step. Let's see if we can, trying to think of the best way to go about this. Okay, we have drawn our circle. From here, let's construct a triangle. We're going to use similar triangles to trisect this angle. No, I think I'm blanking on this. I'm really blanking on this. So I'm going to pause this video. I'm going to stop it. And then I'll make like a part B to this video that is trisecting a line segment. Sorry about that. So just watch the next video so that I can go and make sure that I remind myself of this and don't mess it up right on camera. Okay, awesome. Hopefully that was helpful. If you have any questions, let me know. Otherwise, take care. All right, I'm back like 5 seconds later after hitting stop on that last video. And I've got it. So draw a circle around O and A. We were trisecting an angle. I should jump back into that. Or trisecting, sorry, not an angle, a line segment. Draw a circle, draw another circle, just like we did for bisecting. Let's find one of those intersections. Let's give it a name. So we'll go give it a name. Let's call this point X. I'll show the label. So we've got a new point X. Okay. Now around X, I'm going to draw another circle. And that circle is going to go here, around X of unit radius, sorry. I'm going to draw a line between O and A, and I'm just going to extend it infinitely off. So we've got this line. Where this line intersects with the circle I just drew around X, that's going to be another intersection. So there we go. I'm going to call that point Y. And then I'm going to do this one more time. I'm going to get my compass and draw a circle around Y of radius 1, find where it intersects, put the point there, perfect. It intersects there, it's going to be Z. So now we've got these points. What I'm going to do is I'm going to draw a few lines. So the first line I'm going to draw is I'm going to draw a line between Z and A. All right, let's do it. So line, where am I? Line segment between Z and A. There's our line segment. Okay, we've got this line segment. Next step, let's find a point of intersection here, and we're going to call it A prime. Now, what is that point of intersection going to actually be? Well, it's going to be, if I were to draw a circle of radius 1 around Z, like this, I'm going to call Z prime the point where this circle intersects with the line. So this new point here, just do the circle, intersects with the line. I'm going to call this point Z prime, show label. Awesome. We've got that point Z prime now, we've found. Okay, now I'm going to take the distance between Y and Z prime. And how am I going to do that? I'm going to go like this, compass, boom, boom. So there's a distance. What is the distance? I don't know. I don't know what it is relative to O, but that doesn't matter for now. You'll see in a second. Okay, I'm going to draw a circle of that same radius around X. I'm going to do this. Draw a circle of that same radius and find the point where this small circle intersects with the circle that I drew around Y. That's right here. This point, I'm going to call it, let's see, I'm going to call this point Y prime, because I used Y, the bottom of the Y circle, to get it. Perfect. Let's do this one more time around the origin. So I'm going to take the compass, measure out the distance between X and Y prime, draw that small circle around O, and then find the intersection of that new small circle around the full circle we did around X, which is right here. And I'm going to label that point as X prime. X prime. Perfect. Show label. Perfect. Okay, we've got these points. Now what do we do? I'm going to connect each point to its prime. Z is already connected to Z prime, so we're good. I'm going to connect, and I'm going to use lines instead of line segments. I'm going to do a line between y and y prime, and a line between x and x prime, like this. And now it just turns out that the points where these things intersect, so I might have to actually zoom in here a little bit, the point where the two lines intersect here and here will divide this original line segment from A to O into 3 parts, equal parts. How do I know that they're equal? I can use the measure tool here in GeoGebra, and I can go, what's the distance between these 2 points? It is 2.403. What about the distance between these two? 2.403. What about between these two? It's 2.403. Now that last digit doesn't really matter because it's just a computer error, but a rounding error with the computer. But it is perfectly divided into 3 segments. So hopefully that makes sense. Hopefully you can see what I did here. Now it's, I really encourage you to try this on your own and to follow this along and try and do this line segment trisection. Trisecting a line into 3 equally spaced points. It's hard, right? It's not easy, but we can do it, right? So give it a try, and yeah, if you have any questions, let me know. I'm going to post this, maybe I'll try and merge this, or maybe I'll just post it as like a part B. But either way, hopefully this helps, and yeah, good luck. I'll post the assignments questions shortly, where you can pick one of the questions to do. It's up to you which one you want to submit. And yeah, if you have any questions, good luck. If you have any questions, I shouldn't say that. If you have any questions, let me know. Good luck in the meantime. Okay, take care.